Okay, I think IGCSE exam alternative practical is on Thursday, so I just want to go through this alternative practical question. So I'll try and go through two different papers between now and on Thursday to just give you a thorough guide on how to approach the coursework paper. Now, this particular paper is for May June 2021, and the exam is for 1 hour 30 minutes. Now, once you'll be given a question, and you also be given an insert. So here I have my insert, and so you have to be able to analyze concept in the question using pictures, tables, chart, and that is found within the insert. So quickly, let's have a quick run through. First, this paper is a two-question paper, and usually the first question is on physical geography. So it's either you'll be asked questions in line with things like usually rivers, coast, and weather. So measurement related to these three major aspects are what comes out in paper 4. Then the second question will be on human geography. Usually you can begin to get things on settlement, tourism development, and questionnaires and the rest. So question 1. So a student who was studying weather did a field work to measure and record rainfall at her school. To extend her field work, she decided to compare her results with data from a weather station. She compared her results with data from a weather station at the local university about 50 kilometers away from the school. Now, the student decided to investigate the following hypothesis. So, hypotheses are constructive guess that after you've done collecting your data, then you'll be able to write a particular conclusion about it. So, hypothesis 1 is at the school, rainfall is higher on days when the wind is blowing from the west. So rainfall is higher on days when the wind is blowing from the west. That's our first hypothesis. The second hypothesis is rainfall is higher at the school than the university. And remember, the school from the university is what, 50 kilometers apart. Now, to investigate the hypothesis, the student used a rain gauge. Now, a rain gauge is the instrument that you use to measure the amount of rainfall. So, which two of the following locations should be chosen when deciding where to put a rain gauge? Now, the first thing you need to know is a rain gauge needs to be away from trees and to reduce interception by leaves. That's correct. Now, on concrete, no, that's wrong, because if it's on concrete, more of the water will flow will splash on the soil. There won't be there is no infiltration that will take place, so a lot of water will be able to move into the funnel and give you a wrong reading. On a hillside, no, on a hillside, whether it's being gentle or steep slope, will affect how fast the water is moving. Now, next to the main road, so it is easy to get to the rain gauge. That's absolutely wrong. It should be on a flat land where it should remote from people, so animal and people don't interfere. I think that would be the two major uh, answers. So, placing a rain gauge, you need a level flat land. You need to place it where it will not have interference with people, and it should be on open uh, land with no interference from tree, because tree also help in interception. Now, in the space provided, we are asked to draw a diagram, draw and label a diagram of a rain gauge. Now, the first thing you need to know is that all rain gauge have a funnel first, so I can start with that. So if that's my funnel, the funnel will be inside a measuring, can be inside a measuring cylinder, or you can have a collecting tube. So you can have a collecting tube And this collecting tube should be placed inside larger container, so inserted into the soil. Now you should also have, so this is a funnel. You have collecting casing to collect the water, so the water will enter through the funnel and move into this casing. So you have a collecting casing. So after you collect the water here, the water will now be, you now add the water into a measuring cylinder. So this can be your measuring cylinder, which will now give you the amount of rainfall in millimeters. That's it, 5 marks. Now they say the student here, the student used a wind vane. They used the wind vane to record the wind direction. So you know, wind vane is used to record wind direction, while an anemometer is used to measure the wind speed. Now this was fixed to the roof of the school. Now figure 1.1 insert is a diagram of a wind vane. Now complete the sentence below to explain how the wind vane is used. The letter N shows, so let's look at the insert. Now here I have the insert of a wind vane, and you know, these arrows, the direction in which the arrow faces is where you take your reading. So this indicates south, the cardinal point, north, south, east, and west. So the first question here is the letter this shows what? Now those individual letters shows compass direction. It shows you is your compass direction, which is the north, east, south, and west. Now the pointer arrow shows, now the pointer arrow, which is this, it shows, it rotates to show the direction in which the wind is coming from. So the pointer arrow shows the direction in which the wind is coming from. So shows the direction the wind is coming from. Then the wind vane is located on the roof, so that, now it's on the roof, and the major reason why it's on the roof is so that there is no obstruction, meaning it will have full access to the wind. That's it. Next is, they said the student measurement for each day are shown in table 1.1 insert. Now use the data from table 1.1 to plot the rainfall measurement for day 3 and 16 on figure 1.2 below. So we have figure 1.2. They want us to plot for day 3 and 16. So let me write it here, 3 and 16. So if you look at this, where is day 3? First, day 3 is here, so I will find out day 3 here, and day 16 will be plotted somewhere here. So all you need to do is you go back to your insert and look for day 3 and day 16, and usually you see it is in bold. So I have day 3 is 5 millimeters west. The direction of the wind is west, but the amount of rainfall is 5 millimeters, while day 16 is 2 and is not. So here is 5 and is west, while 16 is 2 and is north. So for day 16, you see this is direction north, so the rainfall here is 2. So if this is 5, first one is 1, so you just plot to this point for 2. That's it. Then for day 5, for day 3, they said it's 5 and it's west. So this is west now, and day 3, which will be here, and the value is 5. So that's it. We are good with that. I will answer that question. Another 2 now. Now they say, do the fieldwork results support hypothesis 1, which is at the school, rainfall is higher on days when the wind is blowing from the west. Support your conclusion with data from figure 1.2 and table 1.1. So back to figure 1.2. They said at the school, the rainfall is higher on days when the wind is blowing from the west. So if you look at this data from the west, so this is the west, and the peak amount of rainfall here, this is 8 millimeters on day 8. So you find out that the amount of rainfall in the school is higher when the wind is blowing from the west. So even with your data here, you can now check to see. So student fieldwork measurement, data from the west. This is from the west here, 8, 4. West again, you have 7. West, you have 5 here. So all you need to write first, the first thing you need to do to get the first mark out of this tree is either you accept the hypothesis or you reject the hypothesis. You must write that. So the first thing I will write here is the hypothesis is true. So for this conclusion alone, you have 1 mark. Now, why did you think hypothesis is true? You give evidence for the other mark, and your evidence must include the use of data. So come back, you find out that here we have 4 different days, and these 4 days, so the 4 days she did her measurement, 4 days from the west have the highest rainfall. So that will give you 1 mark. So 4 days from the west have the highest rainfall, have the highest rainfall. Now you have 2 marks. Now for you to mark the other marks, to get the other marks, you can now bring in data. For these 4 days, you said what is the amount of rainfall? Day 3 is 5. So you can put at day 3 is 5 millimeters, comma, at which other 2 days we have, day 8 is 8 millimeters, day 8 is 8 millimeters. Now you don't have to stress yourself going through that. If you look from the table, it will be straightforward. Day 3, 5 millimeters, day 8 west, 8 millimeters, day 9 west, 4 millimeters, and day 19 west, 7 millimeters. So writing that here will be able to give you your second mark, which you now get the 3 marks. Now you can also decide to do comparison. In that comparison, now you can say from the west, the highest is 8 millimeters, while the north, you can check the highest within the north. Here. I have north 0, 0. Let me see if there is any value again within the north 1. So the highest within the north is 1 millimeters. Always remember to include your unit to get your full marks. Now the next question is to investigate hypothesis 2. Rainfall is higher at the school than at the university. The students use secondary data. Remember, there are primary data and secondary data, and Primary data are the ones you go to the field and you collect the raw automatic data yourself, while secondary data is the ones you get from recordings, you get from newspapers and the rest. So secondary data from an automated weather recording station. That automated means automatic, where you use digital instrument at the university. Now, how is primary data differs from secondary data? So you find out that primary is collected by the student. Sorry, is collected by the student himself or herself. By the student himself or herself. Um, that's one. So find out that primary data is a direct source. It's also a direct source of data, while secondary data is obtained from another source. It's obtained from another source. Okay, that's also correct. Now, here we are asked to give two advantages of using electronic recording instrument at an automated weather station. So simple, here you find out that the values are more accurate. So you can have accurate readings. Now another thing is also reliable, and it's also portable. So it's easy to carry. It's reliable. It's easy to read. Further, it's easy to read, and it saves time. So it's quick to use. Now, they said to compare the rainfall amount at the school and the university, the student plotted both set of rainfall data on the graph shown in figure 1.3 below. So we have complete figure 1.3 by plotting the following information, 2 marks. Rainfall on one day at the university 4 millimeters, and average daily rainfall at the university is, so you come daily rainfall the university, number of days. So at day 1, the average daily rainfall at the university. So where number of days, rainfall on day 1 at the university is 4 millimeters, while the average is 3.2. So let me see. This is the average, and we'll also plot the average and plot for day 1. So day 1 at the university, we're told it's 4 millimeters. So you move daily rainfall in millimeters, number of days, day 1, 4 millimeters here, put your X. Then average is 3.2. So if this is 3, this is 4, that means you have 3, 3.2, 3.4, 3.6, 3.8. So 3.2, which is here. You now draw a straight line, just like this. And that is now your average. That's all, 2 marks. Now they say, what conclusion will the student make about hypothesis 2? What conclusion will the student make about hypothesis 2? Rainfall is higher at the school than at the university. Support your answer with evidence from figure 1.3. So coming back here, rainfall, that is false, because if you look at day 1, find out that the rainfall at the university was even up to like 10 millimeters. So that's hypothesis. So the first thing is your conclusion to the hypothesis. So hypothesis is false. Now, you now give reasons why. You should always give reasons why hypothesis is false. So first, you can bring in the average in this case. So the average rainfall in the university is what we plotted. University is 3.2, while in the school, it is, go back, check the data. This is 2, it's up to 2.2, so it's around 2.1 millimeters. While within the school is 2.1 millimeters. Now you can bring in another point where you can talk about the highest daily temperature. So you find rainfall. So the highest rainfall in the school. Let's go back. You check it. In the school, you see the highest rainfall is 8 millimeters, while in the university it's 10 millimeters. So the highest rainfall in the school is 8 millimeters, while university is 10 millimeters. You are good with that. Now, here they said while doing her field work, the student realized that there was more cloud cover on days when it rained more. Okay, now which one of the following units of measurement is used to cloud is measured in octaves? That's in 8. 1, 2. So 1, 2, 3, 4, 5, 6, 7, 8. So that's octaves. So the numbers that is being covered, if all this is covered, that means that particular cloud have 4 octaves. Then if all 8 is covered, that's 8 octaves, and that means total coverage. Now the next question is, the students observe 3 different types of cloud. Now use arrow to match blah 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 to the table. Now we have 3 types and description. Cirrus cloud, low in altitude. No, that is wrong. Cirrus cloud are actually high in altitude. So already there is only one high in altitude here. So I know this will be my cirrus cloud. Cirrus cloud is high in altitude. It's usually white color, which appear whipsy or look like a feather, and it doesn't bring about rain. While cumulus cloud is a low altitude cloud. So I have low altitude, but cumulus cloud leads to a high amount of rainfall, and cumulonimbus also lead to things like thunderstorms. So it's a low altitude cloud, um, which are separate from each other and appear fluffy, yes, and looks like cotton wool, yes, and it brings about rain showers may occur. So that's cumulus. So obviously the last one would be a stratus cloud, which are low altitude gray color, which occur in layers. Stratus, so from the word stratus, it should bring about stratas. Stratas are layers. So it occurs in layers. Rainfall is usually very light and is described as drizzle. So you should have that at the back of your mind. Then, still on question 1, it said, to extend her field work, the student used a sunshine recorder to measure the amount of sunlight on each day. And you find out that figure 1.4 insert shows a sunshine recorder. So you need to describe how a sunshine recorder is used. So this is a sunshine recorder. So how is a sunshine recorder used? First, sunshine recorder is placed south, facing the sun. So first, you bring it on point. Sunshine recorder. It's a 4-mark question. Is placed south, facing the sun. Now, Then facing the sun, south facing the sun, which is in the northern hemisphere. Um, Facing the sun in the northern hemisphere. Let me just include it. Northern hemisphere. What is now done from there is that the sunshine recorder should always be kept on open space so that there will be no interference. So sunshine recorder should be in an open space. So what will be done from there is that um, the sun rays um, will now make scorch or bonds on a sheet of paper. But before that, you place the paper. So you place a sheet of paper. So the recorder will focus the rays on the paper which will make bonds, which will make quite lines of bonds on top of it. And what that does is the length of the bond will determine the amount of how long the sun how will I put that? I need the line of the bonds will show the length at which sunshine hours. So simple, the lines on the bonds will indicate the sunshine hours. Now, if on the paper, and the paper will be removed each day and be a new one will be placed on it, and if on the paper you find that there are points where there are no bonds at all, then things like either the sun have set or possibly there's a cloud cover, so there is something that was able to interfere with the solar intensity. Now, question number 2. This will be on human geography. See, we'll be looking at tourism now. So students from an international school in Singapore, a country in Southeast Asia, were studying tourism. Now, tourism is an important industry in Singapore and contributes to 10% of the country's wealth. So figure 2.1 insert shows the change in the number of tourists who visited Singapore between 2002 and 2017. So you come back to your insert, 2002 to 2017. So tourists to Singapore. This is the value. So we'll be able to see it properly. So now from 2002 to 20, let's see which question. Now, how many tourists visited Singapore in 2015 in millions? So all you need to do is come back 2015 and the value is this. So you trace it to here. This is around 17 million people visited Singapore in 2015. So 17, that's it. Next is figure 2.1 shows the impact of two global events. The impact of two global events on the number of tourists to Singapore. Now, how did these events affect tourist numbers? Include statistics in your answer. Figure 2.1. So, yes, figure 2.1. Okay, 2.2. Figure 2.1. Global crisis. Okay, two events. We have SARS epidemic and global financial crisis. Okay, how do these two global effects affect tourism? Now, Because of this global effect, what happened? The amount of tourists that visit Singapore decreases. That's the first thing you need to know. So both decreases. Then you bring in comparative data. In 2003, you have 6 million. It decreases from, if this half year 7, from around 7.5 to 6 million. So there was a decrease in the number in Singapore. So you find out that within that period, okay, sincerely sorry for that mini interruption. Now, yeah, figure 2.1 shows the impact of two global events on the number of tourists to Singapore. Now, how did these events affect tourist number? Include statistics in your answer. Now, we've been able to look at that, and you find out that the event, both event, reduced the amount, okay, the number of tourists. Let me use number instead of amount. The number of tourists visiting the area. Now, also bring in statistics, very important. So you find out that in 2003, so in 2003, due to the SARS epidemic, in case you're look at it, SARS epidemic, the number of tourists that visit Singapore was approximately 6. Here, if you look at it, 6 million, and initially it was around 7 point, around 7. If this 6, 6.2, 6.4, 6.6, 6.8, so it's around 6.8 presently in 2002 to 6. So if you minus that, so it's around 0.8 decrease. So you come back, find out that SARS epidemic reduced by 0.8 million. So it was around, okay, sorry, let me check back. This is 8. Sorry, if this is 8, this will be 6.4, 6.8, 6.8, 7.2, and 7.4. Thereabout. Okay, you have 10. Okay, this is 20 in between, and you have 5 times 4 times 5, that will give you 20. So this is in the fourth one, so that will be 7.4 thereabout. Yeah, so 7.4. So if you have 7.4 minus, so it will be 7.4 minus 6, which will give you 1.4. Sorry, so that will be around 1.4 thereabout, 1.4 million from 2002 to 2003. Now, because in 2003 it was 6 million, while in 2002 it was what is it called? 7.4 million. So if you minus it, you give it that. Then for the next one, you now write about in which year do we have the second one. That should be in 2009. So in 2009, you compare the data in that similar format, you get your full mark. Now, suggest 2 disadvantages for local people to have tourists in their environment. Now, tourists can lead to litters. They can litter the environment, litter the environment. So, and when you litter the environment, it leads to what? Pollution, which can be air pollution or land pollution. Another factor is tourists can lead to traffic congestion within the area. Now, tourists can also bring about the building of hotels, which take up land. So land will be used to build hotels, land used to build hotels. Now, another impact is find out that tourists might not um, tourists might not respect the local culture. Respect the local culture. That's it. Now, Singapore has many tourist attractions. Some of these are shown in figure 2.2 insert. So, come back, figure 2.2 insert. You see, they have many tourist attractions. So, we have, you look at the numbers here. We have Singapore Zoo, Singapore Botanical Garden, orchids. So, let's see what the question is. The question is, which one of the following best describe the Raffles Hotel? Tick. Raffles Hotel. Um, so obviously, let's see. Let's go back. Raffles Hotel. That should be 5. So which of that best ticks? Cultural. Raffles is a hotel, so it's not natural, it's not physical, so it will be man-made. Simple. Now, describe the distribution of tourist attractions shown in figure 2.2. So you come back, this is figure 2.2. You find out that usually once you are asked, you draw your cardinal point first. So you use relative location. This is south, north, west, and your east. So you find out that most of the tourist center, most are found in the south. So 2 to 7 are found in the south. So come, mostly 2 to 7 found in the south. That will not give you 2 mark, to give you a 1 mark. Another thing you can look at is, and they are clustered together. So you come back, you are just describing, you're just saying what you can see. So clustered, they are clustered together. Another thing you see, I think there is only one that is found in the north, which is the Singapore Zoo. So 1 in the north, which is, you can write it, Singapore Singapore Zoo. Sorry, there's no R in Singapore. Now, next is this. You can give other points if you want to. Another thing is in the south and it's also close to the coast, so that will also give you a mark, close to coast. Now, the student produced a questionnaire for visitors to complete in order to test some hypotheses. Now, the questionnaire shown in figure 2.3 insert. Why did the student first ask if the person was a visitor? So let's look at 2.3 insert. Now, this is the questionnaire. Are you a visitor or not? Now, why will they ask if the person is a visitor? Now, the basic reason is, so if it's a visitor, not only people who are visitors are tourists or so. So students only want to ask visitors possibly, or they only want to analyze data from visitors. So first, you can write student only want to ask visitors. So they only want to analyze data from visitors. And so if locals are included, the results will no longer be reliable. If locals are included, results will not be reliable. Okay, so next. He said, sorry, the student went to different tourist attraction to use their questionnaire. So figure 2.4 below is an extract from one student fieldwork diary, which describes his method for selecting people to survey. He used sampling method. The survey was done by systematic sampling. Now description of the method. I approach one person who walked past me and asked them to complete my questionnaire. What is wrong with the student description of his method? How should he have done it? Now he used random. Now the basic thing is the description is not systematic. It's a random sampling. That's what is wrong. So the description is not systematic. He used random. Now, how, that will give you 1 mark. Then how should you have done it? Then you describe what systematic sampling is all about. Now, you can say he can decide to ask, every 10th person, or at a fixed interval, every 10th person who pass him, or every 10th person, or have a fixed interval. That's it. Next here is, in class, the student agreed on 4 hypotheses to test. 4 hypotheses. These are shown in the table below. From their questionnaire in figure 2.3 insert, choose the question which provide correct information for this hypothesis and write the question number in the table below. So most visitors to Singapore are over the age of 50. So come back, age, that's question number 2. Question number 2, look at age. So you write 2 here. Shopping is the main reason why people come to Singapore. You come back. Which city or airport? How many days? What is the main reason? That's question number 5. Question number 5. Now, most visitors stop in Singapore on their journey to another destination. So you check. What is 6? Is your visit to Singapore a stop on a journey? That's 6, straight up. 6. Now, there is a positive relationship between the distance people travel to Singapore and the length of their visit. That will be number. Let's go back and see, because this has to do with 2 different numbers. There is a positive relationship between the distance people travel to Singapore and the length of their visit. So come back. Let's look at which city/airports did you travel from and how many days. That will be 3 and 4. So you come back. 3 will show you the distance, while 4 will show you how long they decide to stay. That's all. Now, one student choose to test the following hypothesis. Shopping is the main reason why people visit Singapore. And hypothesis 2, there is a possible relationship between the distance people travel to Singapore and the length of their visit. Now, the reasons people gave for visiting Singapore are shown in table 2.1 insert. Table 2.1 insert. Use the result to complete. So let's look at table 2.1 insert. They want us to use the result to complete the pie chart. Use the result to complete the pie graph, of this figure. Now, they've plotted for shopping, they've plotted for parks, they've plotted for this. In order for it to be fast, if you check it, you see the one they want you to plot. They want us to plot for restaurant and others, because it will also be in bold in order to save time. So restaurant is 5, while others is 11. So you come back, check, restaurant is 5. So between this to this, you have 10. And already, what you can also do to make it very easy is this. You add all these values together. So If I have 3 5 plus 16, that will give me 11, 1, 1, that's 41. Then you add it plus 14 here, that will be 55. 55 plus 10 will give you 65. 65 plus 9 will give you 74. So 74 plus 5 will give you 79. So all I need to plot here, I'll plot 79. So 79 is not up to, sorry, there's a mistake somewhere. 79 plus 11 will give you 90. So there's a mistake somewhere, because the total here should give me 100. So I've missed something. So let me try and see if I could do it again. So quickly, 30. Okay, this will give me 51. Sorry, this will give me 65, 75. So this will be 80. So this will be 89. So if that's 89, then this is 90. So you just leave a little one. And that is for restaurant, and it's represented with a single dot, so you put your dot. Then the leftover is 11. That's all, and that's for others, so you bring in your straight lines. You're done with this. Now, what conclusion will the student make about hypothesis 1? Shopping is the main reasons why people visit Singapore, and you need to support your answers with data. Now, this is quite simple. So use the pie chart. You can use your pie graph and use the figure, whichever. So shopping, so that hypothesis is correct because shopping have the highest percentage. So hypothesis is true. That will give me a first mark. Then once I give my reasons, I will now get the full mark. So first, hypothesis is true. Now, how many percent? Shopping, 35%. So 35% of tourists. 35% of tourists visiting Singapore are majorly for shopping. 5% of tourists are for shopping. That's all. Now, they said to investigate hypothesis 2, which is there is a positive relationship between the distance people travel to Singapore and the length of their visit. The student plotted their result on a scattered graph, figure 2.8 below. So 2 mark. So for 4, this is 7. So this is 4. Where's 7? So if I go with 4, 4, 6, okay, that's around, this will be around 7. Then the next one is 1100. 1100 is less, so this will be 1000. I think so. This is how many? This is 10 boxes, so 5. So here we represent 1000. Let me erase, please. Sorry. So that is 1000 here, and 1100 is this here, right? Good. Or it should be in the middle also, because if this is 2000, 1100, 200, 3, it will give me 1005. So each 2 will represent 1000. So this is 1000. So here will be 1200. So the middle is 1100. So they want me to plot the middle, and the value there is 8. So it's this. So with that, I'm cool. 2 marks. Then do the results support hypothesis 2? There is a positive relationship between the distance traveled and the distance travel. Positive relationship between the distance people travel to Singapore and the length of their visit. Support your conclusion with evidence from figure 2.6. So figure 2.6, distance people travel and the length of their visit. Is there, no, hypothesis is false. Hypothesis is false. Based on that data, there is no correlation. Now, evidence like no correlation is a scatter graph. No correlation. No correlation. Or if you can't remember the word correlation, you can write no relationship. Now, that will give you 2 marks. So you can just bring in any form of paired data in this case because you are comparing between 2 things. So you can say at this kilometer it was this, and at this kilometer in so day it was so number of time they decided to stay within that area to get your full mark. I've given a lot of examples how to use data. Now here, say the student used the result of question 3 in the questionnaire, which is which city/airport did you travel from, to work out the number of visitors coming from different countries. This is shown in table 2.2. Now, use these results to show the number of visitors coming from South Africa and Australia. Use this result to show the number of visitors coming from South Africa and Australia. Now, you should check your key to show you the number of visitors. So you come back, you look at that number of visitors. South Africa is 1 and Australia is 9. So you come back, you look at this. This is Australia. And where is Australia to Australia is what? Let me see, 9, while South Africa is 1. So you come back, South Africa to Singapore, which is, you look at where it's located, it's here. This is Singapore. So it should be from here to Singapore is now just 1, so a single line. South Africa. Then in Australia it is 7 to 9, so you draw your line in that direction. It's 8, so it's within that range, and you're done with that. Now, so when the student check the completed questionnaire survey sheet, they found 3 errors. The survey sheet are shown in figure 2.8, 2.9 and 2.10 inside. Identify the different errors on each survey sheet. Survey sheet 1. Okay. Now, in this one, no city or airport is filled. So you come. No city or airport is filled. That means if you go back, they did not answer question 3. Question 3, no answer. You can put no answer or response. In 2.9, figure 2.9, check 2.9. That should be question number 5, where they tick too many boxes. Question 5, so sorry, 5, they tick too many boxes. Then 2.10, let's see, uh, 2.10, which city? That should be still question 3, because USA is not a city. Question 3, USA is not a city, but is a country. Now, this is a quick walkthrough, not really quick, but please, if you go through it, it's just to show you, give you some of the skills on how to answer alternative to coursework IGCSE question.